trigonometry circular functions wasn't done last year, and there's nothing wrong with that. We're just going to start from the scratch, but we always do anyway. So in trigonometry, I know the very first shape that comes to mind in trigonometry is a triangle, but actually the other main shape in trigonometry is a circle. Okay. And it's called circular trigonometry. You're kind of wondering why a circle is related to trigonometry. You'll see why. So any unit circle, we'll be going through this a few times. So, and my perfect circle is not perfect. I know there's a lot of videos online that teachers do the nice perfect circle. I don't practice that. So over here, we start at 0 degrees. Okay, what's this? 90. What's this? 180. 270. And back to 360. So 0 is the same as 360. There is another way to say these. So these are degrees, obviously. When we go around in a circle, we measure degrees. Does anyone know what the other way that we can measure going around a circle? What is it called? And which part of the circle is it measuring? Perimeter. You're very close. Yes, you're on the right track. Say. We are looking at the circumference, but what's the measure? Okay. We have degrees, which is the angle inside. But we have another measurement, and it's the length of the outside. Yeah, but what's that called? Close. Okay. It's called radian. Radian. Okay. Now, let's think about it. This is a unit circle. A unit circle. What number, when you look at it, is attached to the word unit? What's the number? It's 1. So that means if I go from here to here, it's a 1. If I go from here to here, it's, say, 1. 1, 1, 1, all the way around. So if I have my circumference, what's circumference equal to? Radian. 2 pi r. Okay. What's my r? 1. So my circumference of a unit circle, if I go the circumference all the way around, if I go from here, guys, too much talking for the first class of semester 2. If I go from here to here, I will unravel it. What's the length of that line of an open circle unraveled? What is it? It's not 2, it's 2 pi. So just say, if I cut this circle out and then I laid it out flat, the length of that line will be 2 pi. What's halfway? Pi. Where do I put my pi on this circle though? At what degrees? 180. 180, correct. Is everyone with Tim? Yep. 180 in the same ratio, Perry, we have degrees, and now we have equivalent, which is radian. What's radian again?
Circumference.
The circumference of a.
Unit circle.
Thank you. It's Manny, is it? Thank you, Manny. If I have pi over here, what's at 0, 360? We have 0, obviously. And what's 360 equal to?
2 pi.
2 pi. Thank you. 0 something pi. What's up here? Pi on 2. Excellent. Down here.
1.5 pi.
1.5 pi is correct. Or 3 pi on 2. Because that's 1 pi on 2, 2 pi on 2, 3 pi on 2. 4 pi on 2, 4 pi on 2. Well, what's 4 divided by 2? 2 pi. That's the foundation of circular trigonometry at the moment. So what are we doing? If I want to convert the following, (150 degrees to radian). Let's do this one first. This is example number 1. As I've always had, I've got the photocopied notes so you can tune in. Think about it. You can use 2 things here. Is 180 the same as pi? We can see that there. So in a way, it's sort of like a cheat code. It's 1. If I flip it, because pi is equal to 180, in a way, that's also equal to 1. So when we times something by each of those things, are we changing the value of something? No. So if I go to here, they're asking you, this is in degrees. Okay, this is in degrees. I want, but we're trying to get to radian. We start off with our degrees, Jesse. But I want to either choose this one here or this one here to change our value into radian. Which one are you going to choose? The clue is you choose the one that has the radian on top. You'll see why. Okay, so I'm going to go pi on 180. Apologies for my texters. I'm going to buy some new ones. Have I changed the value of 150 by timesing it by this? I haven't, because this is 1 up here. But what can we start doing now? Timesing it down. Okay. What goes into 150 and 180 nicely? 10. What? Let's go bigger. 30. Let's go 30. How many 30s in 150? 5. How many 30s in 180? 6. What are we left with? 5 pi on 6. We've successfully changed a number that had degrees to its equivalent as a radian. Okay, any radian answers have the pi in it. Are we good? Okay. Who's seen this before? I want to see if anyone's seen this before. It's all new? Okay. Let's do another one. If I ask you to convert 9 pi on 10 to degrees, which one? First one or the second one?
First one.
The first one. Because the degrees is now on top. So I get our value, 9 pi and 10. I times it by 180 on pi. What's going to disappear, Perry? The pi's are going to disappear. Then I can do 9, 180. I can cut my zeros out. 9 times 18. You could do that in your head. 160. Thank you, 10. From all your 2048 experience. Are we good? Hands up if you're feeling comfortable at the moment with this new stuff. Hands up if you're uncomfortable. Okay. All right, let's keep going. This might, we'll see how you go with this. If this does not make sense, I will repeat myself 1,000,000 times for you. Okay, we're still dealing with unit circle. Just going to use a ruler so it's nice and neat. I'm going to start adding coordinates in here. Trigonometry has a lot of aspects of maths all in the one topic, which is why people don't like it. So, what's this called? Theta. Is everyone okay if I do this? The x coordinate and the y coordinate of the point there. Everyone okay with that? Okay. So therefore, if I go that way, how can I write from here to here? What would I write in there? X. And what's this then? Y. Okay. So now let's do some maths. Obviously we're doing maths at the moment. Cosine theta. Do we remember what two letters are represented with cosine? Adjacent and the hypotenuse. From this angle here, pay attention to here. From this point in our triangle, what is my adjacent Maya? It's x. Emily, what is my hypotenuse?
It's the solid line.
It's a solid line. Good. It's that. But we have a number for that. It's 1. That's crazy. Okay. So therefore, isn't it true that if there's a 1 in there, we don't need to worry about that. I can then change my x up here into what? Something theta. What theta? Cosine theta. Okay? Okay, let's do another one. Let's do sine theta. Jesse, sine theta, whatever what from year 9. So, opposite over hypotenuse. Zay, what's the opposite from this angle here? Y. Good. What's my hypotenuse, Manny? 1. We've realized, whoops, that my y can now be a sine theta. What we've done in unit circle trigonometry we are now expressing coordinates on a unit circle with degrees, just to make it more complicated for you. Okay? All right. Let's go a little bit further. Can someone tell me what that is equal to?
Opposite over adjacent.
Thank you, Manny. But let's go further. What goes on top and what goes on the bottom?
Y.
Think?
Y.
Okay.
Sine negative and cosine.
Wow. Good.
What's it called?
Okay. Did everyone see that? Are we okay with that? Did everyone see a sine on cosine is a tan? Because, remember, I can now express my opposite and adjacent differently now with degrees. Are we good? Okay, let's keep going. Maths is a language, so I'm going to focus on the language of what we're doing right now with these questions. Sorry. Now, look carefully. I rubbed it off, but as a reference point, I'm going to put this in here, pi on 2, which is the same as 90 degrees. I want you, this is a number. Cosine through pi on 2, it equals something, but I'm going to give you a clue of how to attack it using the diagram. This is the clue. Cosine. Which coordinate is cosine now? X. Whenever you see cosine, you're thinking X. So what you're really looking for, we want the X coordinate, okay, at an angle of 3 pi on 2. So if that's 1 pi on 2, this is 2 pi on 2, 3 pi on 2 is down here. If you're a degrees type person, you can say what degrees?
270.
270 degrees. I'll give you a clue now. This is a unit circle. Therefore, what's this coordinate here?
0. 360. Or 4 pi. 2 pi. 4 pi over 2.
1 what? 1 0.
Oh, because it goes out 1. But it's on the 0 thing.
Okay, that's 1 0. What's this one here? Huh?
1.
0 1.
Oh.
What's this one here?
-1 0.
Someone's trying to call me.
And the next one, 0, -1.
Yeah.
Maybe 1 0. What's this one here?
0, -1.
0 -1. Good. Therefore, think about it. We are asking the x coordinate at 270. What's the x coordinate at 270? 0. Good. That's 0.
That's it.
Yeah, that's it. Why is it so funny? I'm establishing some foundations because this is going to help you in all the other questions. Can anyone tell me, translate what this is after in everyday language up here? What coordinate?
X.
X coordinate at what?
-3 pi over 2.
-3, yeah. As in degrees?
270.
Negative 270.
Negative.
Because there's a negative there.
Is negative 270 degrees just
Is it what, negative 270
270?
or negative 270 degrees?
Hey, guys, I'm just the messenger. All right. I'm just doing my job. So, look, if we go 0, if I'm going negative, which way I'm going? Up or down? The other way. So,
So it's
look,
90 degrees.
we could say shape 90, 90, 90. That's 3 sets of 90. 270, and Zaid picked up on it. It's just exactly the same as 90 degrees,
Which is also pi over 2.
which is also pi on 2. But what's the x coordinate at pi on 2?
0.
0.
So because it's negative, not straight line.
Yeah.
Make it 9.
Okay. Do you guys want me to stop?
No, I keep going. Love it.
Okay. All right. This one. Let's try this one.
I can get away. So awesome for this.
Okay, let's do this. There's a few ways to do this. Which letter are we after, Gabe? The X or the Y? We're after the Y coordinate. Okay, be really careful here. There's a few ways we can do this. I'll do it one way. I can rewrite this differently. 33 pi on 2. Okay, this takes a bit of practice. I can go back one to the 32 pi on 2. I'll go back to 1 pi on 2. But then I have to add a pi on 2. Okay, these two are the same. Remember, that's a 1. So we've gone back and then we've gone forward to make it equal. But 32 on 2. What's 32 on 2?
16.
Now think about that too. If this is 0 and then I go to 2 pi, okay, how many times do I have to go around?
1.
Twice. 2 pi.
8 more times,
Oh.
okay?
Oh, yeah, of course.
Okay, so remember, let's do it again. I'll do the animation. That's 2 pi, 4 pi, all the way to 16 pi. Okay.
Half of 1.
Are you good with that?
So there's up on.
So
90.
16 pi. What is 16 pi also equal to?
0.
0. You know when you're doing a burnout on the weekend, okay, you're spinning your wheels. When we're doing this, we are spinning our wheels and we're not going anywhere, but there's revolutions happening. Okay? Drive safe on the weekend, please. So, we made it more simple for us. Pi on 2. We go to pi on 2. We look for sine. What sign again? It's the 1 because its sign is y coordinate. That whole thing equal to 1. Okay. There's a few other ones that I can show you, but predominantly that's how we do that one. That's the questions.
What are we looking for?
Are we just looking for the X and Y's?
You're looking for
So,
coordinates.
Is it if the question would be like sine 32?
The next one would be.
So that dot.
Hang on.
I.
I. What's what?
Wait, no. You know, like in a question.
In a question?
What happens if we do the
I. What do you mean?
A, B, C.
There's a whole
ABC. What's ABC?
Question 1A, 2,
No, we don't
1B.
need that.
Yeah. What about them?
Just be like, that's.
Yeah, that's the question.
You're asking a question when you're looking.
Yeah. So I'm doing it. These are examples. These are real questions. Yeah.
That's just
That's what?
That's just
That's the concept.
oh, it's for gas.
Now, do you guys want me to do another one?
You have to tell probably like right question. That's the end.
Okay. I'll write this question. This is how they. All they're saying is evaluate. Let's do this one. Sine 5 pi on 2. Okay. Let's do it this way first. If I want to do the same process, 5 pi on 2, if I take a step back, I take it 5 turns into 4. How much more do I need to make it equal again?
1 pi.
1 pi on 2.
Why not just make like 2.5 pi and do that?
Yeah, which we'll do in a second. There's other ways to do it. So, 4 pi on 2 is the same as 2 pi, which is also the same as 0. Which, therefore, we're just looking for sine pi on 2. And the sine pi on 2, once again, is equal to 1. Yeah. Okay. Now, or as Tim has suggested, we can also go another way. It's really up to you how you want to do it. 5 divided by 2 is 2.5 or 2.5. I just put it in fractions like that. Focus. Okay. In the same way, that's sine 2 pi plus pi on 2. Okay. You can take a step back and move forward, or you can just cut it up, divide, as Tim is suggesting. And we know 2 pi is simply spinning its wheels in a car. So we don't need that, which is 0. We're looking at the y coordinate at pi on 2 once again. And the answer is once again 1. Okay. The last example I've got here is the same process. So I'm not going to go through that with you. It's not always going to equal 1. Sometimes it's going to equal 0. Sometimes you're looking for the negative 1. Okay. Any questions? Okay.